Hi everyone, in this video we will discuss the problem maximum dot product. Previously this problem has been asked in direct I as well. Now this problem says that we'll be given two arrays and we have to find the maximum dot product of both the arrays. Now what do we mean by the term dot product of two arrays? So suppose that if we have two arrays, let's say we have an array A and that array is of size n, and then we have another array B, and suppose that that array is also of size n, assuming, right? So it is not always necessary that the second array will be of size n, it might be of lesser size as well. But suppose that if array A is there of n size and array B is there of n size, then what will be the dot product of both the arrays? So basically when you are talking about the dot product, then you will multiply the 0th guy of the first array with the 0th guy of the second array. If both the sizes are same, then A of 0 into B of 0 plus what? A of 1 into B of 1 plus A of 2 into B of 2, so on and so forth up till when? Up till A of n minus 1 into B of n minus 1. So basically if you have two arrays which are of the same size, suppose that the first array is of size n and the second array is also of the same size, then the dot product will be what? Then the dot product will be A0 into B0 plus A1 into B1, so on and so forth up till A of n minus 1 into B of n minus 1. But there can be circumstances when the second array is of lesser size compared to the first array. Then for every ith element of the first array, there won't be a corresponding element from the second array. Why? Because we cannot use an element more than once from the second array. So suppose that if the first array has got two elements, let's say the first array is there and we have 7, 5 here. So basically you can understand that the size is how much? 2. Okay. Now suppose that I am taking a small test case here. Basically suppose that the B is having value as 8 and you can see that the size of the second array is 1. Now you can see here that as I had already told that the n will always be greater or equal to m. So the size of the first array will always be equal to the size of the second array, or it might be greater. Now when you are going to take the dot product, so what will happen? Now what you will understand here is that either you can do what? 7 into 0. So for the element 7 of the first array, you will say that you will multiply it with 0, and then for the second element, that is for 5 from the first array, you can multiply it with 8. Then you can get a dot product of what? 40, right? Or the other scenario could have been that you could have multiplied 7 with 8 and then 7 with 5, because the first array was having the element 7, so you could have used 8 for that, right? Plus what you could have done is you could have multiplied 5 with 0. So with respect to 5, you would have said that since the number of elements in the B array are lesser, so you would have used a element, buffer element 0 to multiply with 5, and then you would have got how much dot product? 7 7s are 49 and 7 8s are 56. So then you would have got this much dot product. So you can see that there can be various combinations when I will increase the size of the first array and the second array, and whenever the second array will be having lesser elements compared to the first array, then for buffer elements I can use the element 0 like I have used here. You can see here I've used the element 0 as buffer like this or like this. So basically what happens is whenever the second array is of lesser size, then you can do what? You can take the product of the ith element of the array with 0 if you want. Either you can take the jth element of the second array, okay, that is what you can do, or what you can do is you can take, instead of taking an element from the second array, you can multiply the first array's element with 0. So these are the two things. Basically suppose that if you have any element from the first array, suppose that you have got A of I, so then either you can multiply it with B of j. Okay, this situation will arise whenever the second array will have lesser elements. So then you can do what? Whenever you are at the ith element, then you can multiply it with the jth element of the second array. Or instead of that, the second choice can be that whenever you are at the ith element and suppose that you can use a 0 element as buffer, then you will multiply 0 here instead of B of j. Okay, so I hope that this part is pretty much clear. Now there can be multiple possible ways, because you can see if I had taken a very small test case here, so there were two different answers and the maximum out of that was 56. So the maximum dot product was 56, so you will return that. So there can be multiple possible ways, there can be many possible ways here, because if I will suppose that I have an array A and suppose I am having 7, 4 and then 8 and then 9. Suppose this is the array, and suppose that the second array is what? Suppose that the second array is basically having the elements like let's say 15 and let's say 24. Okay, then two of the elements will be there in the first array that will not get corresponding element from B array. They might have to get multiplied with 0. So there can be various possibilities here. So that is why in order to cover all possible ways and find the maximum out of that, what concept comes to our mind? Recursion comes to our mind. And since they will be overlapping sub problems, so then we will apply DP into our code. That is, if a sub problem will be already calculated, then what we will do is we will not calculate it again and we will return the already stored answer. So here in this case also you can see how many zeros you have to use. So the number of zeros that you have to use is 4, that is the size of the first array, minus 2, that is 2, because I have to still use 2 zeros. So whenever I will be at a particular element of the array A, so either I can multiply it with a corresponding element of the B array, or what I can do is, if I have the opportunity to place a 0, if the number of zeros that I can place, if they are greater than 0, right, because as I will keep on using 0, so I will keep on decreasing the number of zeros, right, that I can use. But suppose that if I am at an ith element, so first thing, as I said, like you can multiply that ai element with a bj element in order to get the product. Or what you can do is, if you still have zeros remaining, if you are allowed to use zeros, if you still have some zeros that you can use, then you will do what? Then you will multiply that ith element of the array with 0. Okay, so this is what you can do, and out of these two choices you will always choose the maximum one, because you have to maximize your dot product. I hope this makes sense. Let's try and implement the code now. So yes, what we will do here is, first of all, we will write a solve function, suppose. But before that, I need to find the number of zeros. So let's say the number of zeros will be nothing but n minus m, because the n will always be greater than m. So if the n and m are same, then the number of zeros allowed will be 0. Otherwise, there will be certain zeros that would be allowed. And now I need to return a solve function. And in this particular solve function, what are the things that I need to pass? So I need to say that we will start from the 0th index of the first array and the 0th index of the second array. Then what we will do is we'll pass the array A, we'll pass the array B as well, and then we will pass n and m, that is the size of the first and the second array here. And after this, we'll also pass the number of zeros that we have right now. Okay, and this function is going to return us the maximum dot product, right, after considering all possible ways. So then we will say that we'll have int solve function right here, and in this we'll be at the index I, will be at the index j, like we'll be passing the index I from the first array and index j from the second array. Then we'll have n, then we'll have m, and then after this also I need to pass the arrays. So let me pass int a array, and let me pass the int b array as well, and then after that I also need to pass int zeros. Okay, now after this, what I will do here is, if suppose that what happens is, if either the first array or the second array gets exhausted. So if suppose that I value is equal to n, okay, so let us say that if I value is equal to n, or the j value is equal to m. If either suppose that the first array or the second array is exhausted, then for the rest of the time the values that you'll get is 0. So that's why you can return 0. Otherwise, what you will check here is, you will check that first of all, choice 1 is what? The choice 1 is that for ith element of the array, you can multiply it with the jth element of the second array. So then you can say that it will be nothing but a of I into b of j, right? Plus what? Plus you can call the solve function for I plus 1 comma j plus 1, because since you have used the ith and the jth element of the first and the second array respectively, so you need to move your I index by 1, and you also need to move your j index by 1. Then once that is done, so you will do what? You will pass the A array, you will pass the B array, and then you will pass n, m, and the number of zeros will still remain the same. Okay. Otherwise, the choice 2 will be used when. So we can say that the choice 2, let's mark it as 0. Now, what is the choice 2? Suppose that if you have zeros remaining, like if you can use some zeros, then you will say that the choice 2 is that I multiply the ith element with 0. So therefore, the value would become 0. And then I call the solve function, where I will do what? I will say that I need to move to the I plus 1th element of the first array, because I have multiplied the ith element, and then my j index would remain the same because I haven't used the jth element of the second array. Then I'll pass a comma b comma n comma m, and my number of zeros that I can apply now will reduce by 1. So I'll write zeros minus 1. And then after this, what I will do is I will simply say that I need to return the maximum of the two choices, because ultimately I want to maximize my dot product. So I'll return the maximum of choice 1 comma choice 2 here. Okay, let's try and compile this code to check if it is working fine or not, and then we'll discuss further. Okay, so I have not written int correctly here. So yeah, in the definition of the function. Now let's try and compile it again. So it does work fine for the samples. You can see that the answer is 107. Let's try and submit it. Obviously, it will give us a TLE error. Why it will give us a time limit exceeded error? Because of the fact that we are having a lot of overlapping subproblems, which if are already calculated, so we don't want to calculate again. Okay, so that's why we will now declare a DP array here, which will be storing the I index and the j index. So we'll have a n cross n DP array. So we can say that vector of we will be declaring vector of vector int, let's say DP, and then we'll have n comma vector int n comma -1. Okay, so we have declared this DP array, and initially we have initialized every element as -1. Then after this we'll pass this DP array here, and then we will pass this DP array in all the function calls. So here also after 0 will pass, and 0 -1 in this function will also pass, and then in the function call here vector of vector int ampersand DP, I'll pass it, right? Now after this what I will do is, if the DP of ij is not equal to -1, if it is not equal to -1, then what I will do is, if the state is already calculated, then I will directly return the value, that is DP of ij. If that particular state is already calculated, so we don't want to calculate it again, we will directly return the value. Otherwise, if it is not calculated, then we'll calculate the maximum value, and then we will store it in our DP of ij, and then we will return it, so that we don't have to calculate that state again. Let's now try and compile this code. So it does work fine on the samples. Let us submit this code to check if it is getting accepted or not. It should get accepted now. So you can clearly see that our code is able to pass all the test cases that are given here. Now talking about the time and the space complexity of my approach, what will be the time and the space complexity here? So the time complexity is going to be nothing but order of n square, because you are having index I and j. So maximum I can go till n and maximum j can go till n. So the number of different states that you will have is n square, right? And talking about the space complexity, so since we have a n cross n DP array, so the space complexity will be order of n square. So time and space both are square in nature. I hope that you have understood this problem clearly, which has been asked previously in a lot of companies. And if you have understood this throughout, make sure to comment +1 or understood in the chat. And thank you for watching this video, guys. Keep coding.